This is a continuation of my review of exponentials. So in this video, we're just going to do more practice with graphing and solving equations. So specifically, I'm going to graph these three equations here, and then I'm going to solve all of these equations here. So this video continues extra practice exercises from my review video on this topic. So if you want to see a full breakdown of these topics, I'll drop a link to that in the description. Also, I do have a free PDF version of these problems with an answer key at divideandconquermath.com. Just go to the review section. So we are going to go ahead and jump right into the graphing. And so I talked about in the video. So you really just need like a couple of points to kind of get the shape going, as long as you know what the shape is. So I would probably just plug in -1, 0, and 1. You can plug in like -2 and 2 if you want more points, but I think you can get the general idea from these. So remember, 3 to the -1, so plugging that in, that's just going to be 1 over 3. So that's going to use what we know with negative exponents. And then 3 to the 0, anything to the 0 power is 1, and then 3 to the first will be 3. So these are the 3 points that I need to graph. And you can really just approximate them. So like -1, 1/3, I guess I'll put it somewhere around here. 0, 1 will be right here, and then 1, 3 will be up here. Now, the other thing to remember with this is that you do not want to cross this axis here. So this acts as an asymptote, so we are not going to cross that. Instead, I'm going to let my graph just ride along that and move up like this, and we've got a pretty good shape of that graph. So up next, let's try y equals 1/4 to the x using the same 3 points. So I have -1, 0, and 1. So the only thing with these fractions then is if I take 1/4 to the -1, so what that negative exponent does is it just flips it into 4 over 1. So this will just be 4. Anything to the 0 power is always 1, and then 1/4 to the first will just be 1/4. So again, I'll just kind of approximate these. So I'm going to have -1, 1/4, so that's going to be right here, 0, 1, and then 1, 1/4. So again, I just don't want to cross, so I want to remember this is really an asymptote here. So I'll just mark that for myself. And so then I can just kind of come through. I'm not going to say that was my straightest curve, my smoothest curve, but we got the job done, right? Okay, and so for our last one, so I have y equals 1/3 to the x. So same idea here. So I'll plug in these 3 points. So 1/3 to the -1 means this is just going to become 3 over 1. So this will be 3. Anything to the 0 power is 1, and then 1/3 to the 1 will be 1/3. So again, I can just kind of approximate these. So I have -1, 3, 0, 1, and 1, 1/3. Okay, and I'm not going to cross that axis. All right, just kind of fill that point in there. Okay, so now I'm going to solve these 5 exponential equation type problems. So if you want, you can pause here. Otherwise, I am just going to start plowing through these. I did talk about how to solve these at length in the review video, so I'm just going to hop to it. Okay, so starting with the first one, so I've got 4x equals 16. So in this case, I can write 16 as a power of 4, and so that's really what you're looking for. It's just what can you write it as the same base as we see here. So I have 4 to the x equals 4 squared. So from there, you just take your 2 exponents, and this one's easy peasy. It's just going to be x equals 2. So the same thing is going to hold true for b here. So I've got 5 to the x equals 1 over 125. So 5 to the x, I'll just leave it alone. But how could I write 125 as having a base of 5? Well, obviously this has to have a negative exponent, and I say that's obvious because it turned into a fraction. So whenever it turns into a fraction, that is your light bulb moment that it has to have a negative exponent here. And then 125 is really 5 to the third. So this is just going to be 5 to the -3rd. And now that I know that, so then it's nice and straightforward again. So this is just going to be x equals -3, and that's all I have to do for that one. Okay, so now we've got slightly more interesting exponents here. So I've got 2 to the 3x and 16 to the x minus 2. So you have to just kind of think about the context. So in the first one, we had 4, so we were able to, and we had 16, so we were able to leverage that. But now I have 2, so now I want to write 16 again with a base of 2. So this is going to be 2 to the 3x equals 2 to the, let's see, 2 to the 4th, right? So 16 is 2 to the 4th. And so when you do that, you want to preserve that other funky exponent. So you're going to set up a set of parentheses, and then what you're going to do is you are going to multiply these together. So I'm going to have 3x, so I'm just going to take this exponent here and just boop, put it down. And then this is going to be 4 times x minus 2. So now I can go ahead and distribute that. So that's going to be 4x minus 8. And then we just solve as usual. So I can go ahead and subtract off the 4x so that I get negative x equals negative 8. And of course, if I divide both sides by negative 1, then I'll just get x equals 8. And so that will be the solution in that case. Okay, so moving on to D here. So now I have 25 and 125. So I can see just by looking at these, I'm going to have to rewrite both bases. And I did talk about how to do that in the review video. So 25 can be rewritten as 5 squared. And then I can bring that 4x along. I just want to put the parentheses around it. And then 125 can be rewritten as 5 to the 3rd. Again, put parentheses around that. And then rewrite this as 2x minus 4. And from here, now what we're going to do is we're just going to distribute and multiply these exponents together. So 2 times 4x will be 8x. And then 3 times 2x minus 4, so that's going to be 6x minus 12. And from here, now we can just solve as usual, right? So I will go ahead and subtract off the 6x to get 2x equals negative 12. Divide both sides by 2, and you get x equals negative 6. And so that will be it for that one. And so E is very similar to the last one, except now we have this fraction. So just like the earlier problem, the second you see a fraction, that is a slam dunk that you are using a negative exponent. So I need to rewrite both sides with a base of 2, right? Because 8 and 16 can both be written with a base of 2. So 1 over 8 will be 2 to the negative 3rd, and then I will put parentheses around that. And then 16 is 2 to the 4th, and then I've got 3x. Plus 2. Okay, and so from here now I can just distribute. So negative 3 times 2x will be negative 6x, and then 4 times 3x plus 2, this will be 12x plus 8. And now we can just go ahead and solve as usual. So I can go ahead and subtract off the 12x. So this is negative 18x equals 8, and divide both sides by negative 18. And so I get kind of this crazy looking number. So let's see, this will simplify to negative 4 over 9. But that is it for that one. And okay, so that brings us to the end of that. So just as a reminder, I do have a lot of other topics in my review series. So if you're interested in checking those out, they always come with a refresher video, practice problems, answer key, worked out video solutions, everything you need. So go to divideandconquermath.com, go to the review section, and you can find everything for free. Otherwise, I hope to talk to you guys in another video. Peace.